Practice forming compounds and finding formula mass. Here in this worksheet we have an example that's already worked for you, sodium sulfate. The first thing you need to do is find the ions with their oxidation number, and you're going to do that by looking at either your periodic table or your polyatomic ion chart, depending on what it is you're looking for. So this one starts out with sodium, so I look up sodium on my periodic table. It's Na. Since it's in group 1, it'll have a +1 charge. So I write down Na for sodium and +1 as its oxidation number. Then I find sulfate. Remember, an ate or an ite ending means that I'm going to find it on my polyatomic ion chart. So here's sulfate, SO4, and it has a -2 charge. So I write down SO4 with a -2 charge. Now in order to make the formula, the chemical formula for this compound, I'm going to need to put these two ions together so that they cancel out to 0. If these two numbers already add up to 0, then all I'd have to do is write out the ions together as a compound. So I'd have NaSO4, but in this case they don't add up to 0. So what I do instead, and this is something we did in a former worksheet, we take those two numbers, not the charges, just the number, and we cross them over to become the subscripts of our compound. So I take this 2 and I bring it down to become the subscript for Na. So I have Na2, and then here I'm going to take my 1 and bring it down as the subscript for SO4. But I don't write 1s. 1s are understood to be there, like there's one S in SO4 because there's no number here. So I'm not actually going to write that 1. It is understood to be there. Now just so you're aware, if I'd had a number that I had to bring down here, let's say if this had been a +3 versus a -2, I would need to bring down that 3 as a subscript, and before I could do that I'd have to put SO4 in parentheses and then put the 3 outside of parentheses. Since we just have a 1 that would go here and we don't have to write 1s, I don't put SO4 in parentheses. Only if I need to put a 2 or a 3 or some subscript out here after sulfate would I need to put it in parentheses. Okay, so I have Na2SO4 as my formula for sodium sulfate. Then to find the formula mass, do the same thing you've been doing on the other worksheets. Add up the mass of 2 Nas, an S, and 4 Os, and you should get this mass. Go ahead and try that for yourself to make sure that you're doing these right before you go in on your worksheet. Now I've already done the first one for you, but I want to show you why I did it this way. Dichlorine, remember di tells us 2. These right here, 1 through 4, where there's an X right there, this X is telling me I should not look up the ions because these are all covalent compounds. Remember, in covalent bonds the electrons are shared, and so we have to write, and so it can bond in different ways. So we have to write these prefixes, di, tri, and all that, to let us know how many elements are there in each compound, how many atoms of each element, I should say. Our prefixes are down at the bottom of your paper in case you've forgotten which ones they are, which number goes with which prefix, so that's there for your reference. So when I do this one, I see dichlorine, which means 2 chlorines. 2 chlorines. This does not tell me the charge of chlorine, it tells me how many there are. Heptoxide, again, would be 7, and oxide is oxygen. I changed the ending of oxygen to an IDE to make it oxide, to let me know that oxygen is in a compound with this element before it. Alright, but remember, oxide is oxygen with the compound ending on it. So I've got dichlorine, Cl2, heptoxide, 7 oxygens, O7. Then I'll add up the mass of 2 Cls and 7 Os and get my molecular mass for Cl2O7. So you'll do these the same way. If there's no prefix in front, had this been chlorine instead of dichlorine, remember that there would just be 1 Cl. So do those as covalent compounds using the prefixes. When you get down here, you're going to do these just like we did the example sodium sulfate. So you'll look up cesium, you'll look up sulfite, put their symbols and their charges here. If they add up to 0 already, just write them out. If they don't, cross those charges over for the subscripts of your compound. Now I've noted on here that zinc is a +2 charge. It is one of the transition metals. And so typically the transition metals are noted in their name with the charge of them, but zinc tends to only bond as a +2. So it's just kind of one of those that's understood to always bond that way. But I went ahead and put this +2 in there so you know to use zinc as a +2 when you put it over here for your ions. And then down here in 10 through 14, let me move this up. Don't forget that this number in parentheses, the Roman numeral in parentheses, tells you the charge of the transition metal. So that's what I was saying here, is really your transition metals usually would have a 2 in parentheses here to say this is zinc with a +2 charge, but we don't have to do that with zinc because zinc tends to only bond one way. Copper, though, can bond different ways, so I have to tell which way it's bonding. It's going to bond as a +1, so I don't have to look at the periodic table to figure out copper's charge. I know it from this number right here. So we know that iron will be a +3 charge, and so on. IV is 4. So I just write out those charges here along with the charges of the second part. One last thing I need to show you, chlorine gas and oxygen gas. Chlorine and oxygen will never be found alone by themselves. They're part of a group of elements called the diatomic elements. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine all are what we call diatomic elements. And hopefully you have them marked on your periodic table with some sort of an asterisk, because I did put that in the instructions for when you made your periodic table to mark those as special. And the reason why is we'll never find them by themselves. We might find oxygen in H2O, right? It's bonded with hydrogen in water. Or if it's by itself, like oxygen gas, then we don't see it as just O. It will be O2 because it is diatomic. And remember, di means 2. So since we have a diatomic element, we don't find it as just O, we find it as O2. Chlorine is the same way. So if you see any of these elements, hydrogen, and then here start at number 7, nitrogen, and make a 7, NOF, and then Cl and down. Okay? So when you do these, they're diatomic. Be careful with the mass on that. If you do still have any questions as you're going through these, please make sure you come and ask.